Welcome back to the shop. It's day 4 of this project. Kind of a cloudy day. I had to run up to Bangkok today anyway. Getting a late start. So what I get accomplished on day 3. Day 3, I set the seat. Set it up so I got the same height from center of the seat, center of the bottom bracket. I installed the headset, stuck fork in. It's kind of just hanging in there by tension right now. This is my anti-fork drop mechanism. And I spent a whole lot of time scratching my head and doing multiple measurements of my existing bike, the one I've been riding for the last 17 years. And comparing those measurements to this frame. Now I know what the frame geometry on this is because I've got the specs. I don't have such specs on my other frame, so I had to make measurements. And you spend a lot of time worrying about stuff like stack and reach. And those are kind of general indications. They're not going to be precise indication, they're general indications. So what I think makes a lot better sense is your reach is actually easier to measure if you measure it from the very center of the seat, where if you drew an imaginary line through the seat post and it came out the seat, it would come out right there where I've marked it. And that's basically where you're going to be with your sit bones back here. So the reach is actually not just that line that's perpendicular to the center of the bottom bracket over to the center of the head tube opening. The actual reach is going to be the reach of the stem, and then actually again the reach of the shifters. Different shifters have different amounts of reach on it. My existing shifters on the bike up top is 17-year-old Campanola Chorus, and if you look at those and compare it to a modern shifter like these Ultegra Di2, they look like babies. Little tiny little horn bumps coming up, whereas the Di2 has almost a handle you can put your palm around. Furthermore, the reach of that shifter from where it bolts on to the bar to where you're going to grab the hood is about 40 millimeter longer than the reach on those Campy quarter shifters. So I was worried about the length of the stem that I ordered. That's the Yoeleo 2nd generation stem. You can see it's a 40 wide, 90 mil stem, and it states the reach at 80 mil and the drop 120. So 80 mil is exactly what I have on the bars on my other bike. The drop on the other bike's a little bit more, it's 125. But I started out with a 120 length stem 17 years ago. I was younger then. And it's now a 100. I ordered this at 90 and I thought, man, maybe that's going to be too short. And of course, it's an integrated bar stem, so there's no cure for a too short stem unless you jigger around with saddle fore and aft, and that's not always going to be the right solution because you have to get your body aligned properly over the pedals, or you just have to replace the stem and the handlebars, which isn't the worst thing in the world. It's just money. It's made to be spent. But the bottom line is, if you look at this, when they talk about the reach of the stem, they're talking about from the center of this bore opening to the center of the bar. Now this is 90 from there to there. My current stem, as I mentioned, is 100, so it's another centimeter. However, the bars I have up there are 31.8. The bars here, I don't know what that is. That's probably 40, maybe more. Check it and see what it says. That's 40, 43, 44. So that's 13 mil more than the bar I've got. What does that mean? Well, when they talk about the reach of the handlebars, they're measuring that from the front edge of the bar to the face of the drop. Well, my bar is 13 mil longer, wider than the current bar. The reach is the same, but basically this bar has a 13 mil greater reach overall. So that kind of counteracts that 10 mil difference between the stem length. What's really interesting to me is once I put the shifter on here and checked it out, those Campy shifters are a good, wow, 1.5 inches shorter reach than the Ultegra shifters. Bottom line is, top tube on this bike is 56, top tube on the other bike is 56. This bike, even with the shortest stem that Yoeleo makes for it, this bike has about 40 mil greater reach. The effective reach, I'm not talking about this reach from here to the center of the bore opening. I'm talking about the effective reach. When you're sitting on your saddle, your body extends, your arm extends, your hand extends to grab the hoods. That's your reach. That's one measure of reach. You might also say, okay, the reach is when my hand is on the bar. Well, I think my hands are on the damn shifter hoods more than they are on the bar when I'm riding. I don't know about you. Seat tube on this bike is 52. Seat tube on the other bike is 56. This tube is different measurement. The head tube on the other bike is 5 mil greater than this. It's a 155. It's a 160. Fork length is exactly the same on both bikes. I don't know what the rake is on the old bike. This is 45. So assuming the rake on the old bike is also 45, then the length from the ground to here ought to be only 5 mil shorter than the same distance measured on my old bike. What I can say for sure is once I set the saddle up, I fixed the handlebars in this position with all those spacers. That's all the spacers Yoeleo sent me. This is more spacers than I have on the bike up there, but the other bike has this finishing cap it's probably a centimeter taller than this one. So what I was trying to do is I'm trying to get the same amount of drop from the level of the seat to the level of the handlebars. And I know what the drop amount is on that old bike, and I like it. It's comfortable for me. So what I want to do is get the drop from this seat to the handlebars to match it up. I think those are the important measurements when you come right down to fitting the bike for you. Stated reach and stack height is just kind of a general indication, but as I've been explaining, the actual reach of the bike takes in other considerations. Length of the stem, width of the bar, the reach on the shifters. This bike has actually got a greater reach and slightly more drop, even with all these spacers, slightly more drop from seat to bar than my existing bike. So I can't lower the seat because it's right for my leg. So I got more drop and I got more reach, which means I'm going to be extended more. So that's what I discovered yesterday. The only way around fixing that is put more spacers on, which I don't want to do. But then again, that setup up there has been what I've been riding for 17 years. And when I bought that bike, I weighed about, I don't know, 15 or 18 kilograms more than I do now, and I was out of shape and I was working hard for a living in the kitchen. I wasn't flexible. I've been doing an awful lot of riding. I think it's worth finding out if I'm okay with stretching out a little bit more. I'm sure I am. But that's what I discovered day 3. The other thing I spent a lot of time talking about on day 3 is what I'm going to do for the wiring. I've got Di2, but this is a rim brake frame. And that's the port where you can mount the Junction A for the Di2. But the way it came was with this alternate plate that has 2 cable entry ports. If you're running mechanical shifters, that's where the cables go in. Go down to your derailleurs. Well, I don't have mechanical shifters, I got electric. So I'm trying to figure out how I'm going to wire it, and I got some good ideas watching a GP Llama. Also talking to Terry Seidler. He's got a website called bettershifting.com, and he's written a great guide, very informative, on Di2 setup, everything you need to know basically, and it's well done. I've read some others that aren't so well done. My fix, there's no cable routing through the stem. If you bought the disc brake version of this same frame, you can. They have a different molding up here where you can actually run the cables through the stem into the down tube. Now, I don't have that. I've got this port on the down tube. Of course, I got a port there and one port back there for the entry of the rear brake cable. So what I intend to do is I'm going to wire the left shifter to the right shifter. I'm going to put the wireless sending unit in the bar here. I'm going to put the Junction A here. And that connects everything up front. Brake cables run down here, in there, out there. This one's going to go around to the left side of my top tube. Down here, in there, out there. This one's going to go straight down and connect to the front brake caliper. There's an extra lead there. That puzzled me for a while because I couldn't figure out what it was, and then I went, duh. That's in case you want to put Junction A in the left side. Yoeleo put it a lead for either or. And you got the leads coming out in there. They've actually color-coded the tubing so you know which lead is which. There's one that's a little bit frosty and one that's a little bit more translucent. So day 4 in the shop, I think I'm going to start doing some cable routing in the bars. And after thinking about this a whole awful lot, my goal was to make sure that all the cables that could be hidden are hidden. Obviously, you're going to see a brake cable coming to the top tube of the frame. You're going to see another brake cable going down there. Why do I want electronic cable visible? Well, GP Llama did something really cool. His is a disc brake frame, hydraulic disc brake, so he's got a port on the down tube naturally and an exit port back here for the disc brake caliper. What he did the same thing. In fact, I got this idea how I'm going to wire this up from his post on YouTube. And what that left him with was he had to connect the cockpit to the rest of the components on the frame. So he didn't use the Y splitter. By attaching this to this with a cable, it eliminates the need for a Y split. So all he had is the battery lead plugged into the left shifter, running through his, and then it's hanging outside the frame. But what he did is he shrink wrapped it to the battery cable, so it is what it is. It's not that big of a deal. And I can't do that. I don't have disc brakes. But I have a port up here for my rim brake and an exit port there. So one of the thoughts I had, but it gives me pause, is doing what he did, but shrink wrapping it together and feeding the battery cable through this port. And the brake cable is going to come out here, but take the battery cable, run it to the seat post, and hold your breath, drill a hole in the seat post, run the cable in, drop it down. Now there's room inside here because this is a D-shaped post. It's not going to take up all the space in there. So I could drop the battery cable down and then have it plug into the port on the bottom of the battery mounted in the seat post. Battery would be mounted in here, down in there. I think that would work, but of course you got to drill a hole in your carbon fiber seat post. And I've read some stuff where people said, nah, I wouldn't do that. And other people said, yeah, you can do that. If it fails, it fails. It's not going to be a catastrophic thing. Unless, of course, the broken seat post went into your butt. That wouldn't be cool. But where's it going to break? It's likely to break wherever you drill that hole, if it breaks at all. Anyway, that's option one. That would get rid of that cable from sight. But that's kind of a bold idea. The other option is, look, it's not the end of the world. You've already got these two cables hanging down, so it's not like everything's invisible like it is if you get a through the stem route, internal, full internal. So I'm going to have battery cable coming out of there. Why not run brake cable coming out of there? Why not run the battery wire in and out, shrink wrap them together? Or no, that's option one. And it's now battery lead wire hanging down here. I could just run it to the out front computer mount, put a zip tie on it. You wouldn't see the cable at all up front. And then it's going to have to drop down, wrap around the head tube right here, and then run it into one of these mechanical shifter ports, and then it's down in the frame. So basically we're talking about a stretch of battery lead. Not a big deal. I think that's probably what I'm going to do. It's just easier, and I don't have to drill a hole in the seat post. Even though the experiment scientist that I am makes me want to kind of do it, but I think I'll do it on an old bike, not on a brand new frame. So anyway, day 4 in the shop. Start some wiring. You might be wondering, you might have seen that. What the heck is that? Well, that's Hambini engineering bottom bracket, partially pushed through. And I covered it up over there so it's not going to get some dirt in there. But I was real curious as to whether or not that bottom bracket was going to go into this frame after I used the go no go tool that Hambini drew and I had a machine shop make. That go no go bit into the opening maybe 3 millimeters, maybe 4. So I sent him an email saying, well, it does fit in there, and the no-go side, the 41 mil side won't go. The 40.95 side will go. So my assumption was if any of it goes in, when you start pressing it, it'll go in. So I sent Hambini an email and photo of the go no go sticking in the hole and asked him that. What do you think? And he wrote back, it ought to go in more than that. I think it could probably do with a whiffle, which he means to take a bore device and grind out a minuscule amount of the carbon face on that bearing seat in the bottom bracket. Well, once it's in, as far as it is, it's not coming out. I guess I could get a tool and remove it. But the fact is, once I started pushing it in, I heard a couple creaks. But I can actually feel the face of the bottom bracket protruding beyond the face of that seat in here. And it started getting easier, so it's going to go through just fine. But I'm not ready to do it because I have some fiddling around to do in the bottom bracket, don't I? With the electronic wiring for the 2 mechs and Junction B here, a wire going up to the seat post where I'm going to stick the battery. I got to get that done, and then I'll push the bottom bracket through. But anyway, that's the idea for today. See what happens.